Welcome to another lesson. We will look at MATLAB 1D array applications. Let's start. A lot of what you will see here will be things that we did before. So we look, for example, at some rounding functions. So here we have this is a 1D array that has certain numbers, and you can do different rounding function like floor. This function rounds the value to the nearest integer toward negative infinity. So basically I want the floor of this number. Let's say I have 1.9. What is the floor of 1.9? That's one. Fix, similar to floor, but it has a slight different usage, which I will show you. So this will nearest integer toward negative infinity, this toward 0. I will just show you the difference, but it's the same. Fix, so for example 2.9. What is the fix of 2.9? That would be 2. Seal, that would be the opposite of floor and fix. So for example, what is the seal of 2.9? That would be 3, for example. And we've looked at the round function before, and how to round well with where n is a positive number, that would be digit to the right, and when n is a negative number, that would be rounding digit to the left. So it's easier, to look at these things and to talk about them by an example. So let's just say A, and let's try all of them. Array A, that would be equal to this row, this column vector here, the floor of column vector. So the floor of column vector, we will expect this to find the floor of this value. So the floor of 1.9, that would be 1, that would be 1, that would be 0, and we will see now the difference. Fix will give you the same with some slight difference, which I will show you. Seal, so the seal of 1.9, that would be 2. For example, the seal of this guy, that would be also 2. And round. Okay, let's just run it and see it. So we come here, we do Control Enter. So now, so that is my original array A. The floor of A, you see, this is 1.9, that would give you 1, that would give you 1, that would give you 0. Same as fix here, but for now, that's when floor and fix start to differ. The floor of this one, you expect this to be -1, which is -1, but with fix you got the 0. Why? Because the fix function rounds the value to the nearest integer towards 0. So similarly, the floor, it's rounding towards 0. So similarly, this one will, the floor of this one you would expect to get -2, which is -2, but with fix you get -1. I mean, that's the only difference, because it's not rounding to infinity. It's not going down to infinity, it's going up to 0. I mean, that's the only difference. Seal, I mean, seal is seal. So the seal of this guy is 2, the seal of this guy is 2, the seal of this guy is 1, the seal of this guy is 2. Basically, seal you are rounding up. So seal you round the nearest toward positive infinity, you're rounding up. And here, rounded, just round. So round 1.9, the round of this, that would be 2. The round of this, that would be 1. The round of this, that would be 1. The round of this, that would be -1. So round of this guy, -1. The round of this guy, -2. So rounded, just round. Okay, so really nothing new here. The only two new thing is I'm not sure, we didn't look at floor and seal before. These are commonly used. If I want to see what is round like what is the floor or seal of this number, and then fix. Now you know the difference between floor and fix. Okay. Let's do an example. A package delivery service charging a minimum of $100 per package that is less than or equal 50 pounds and $5 for each additional pound. Delivery charge is calculated by rounding up to the next pound, calculates the delivery cost for like a package that is that weight. Okay, so the weight, so we have the weight is giving like this, is extra weight. So if you have extra weight, that would be like the weight minus the minimum weight of 50. Okay, that's like the extra weight. And then the cost would be the minimum charge for the 50 pound, which is like 100 plus $5 for each additional pound rounded up. So like, let's just run this. So the extra weight is like 25, so now 25, they don't just round it. So if it is just rounded, if we just like use the normal rounding, so that would be the extra weight would be like 25 pound, but they round it up. So basically rounding up means that they use like you can use seal. So the extra weight, that would be the not 25.3, but like you seal it, like you round it up. So seal this guy, and then that should be like 26. So we got like 26. So that's like the extra weight, and the total cost would be like the minimum charge plus the extra weight time like $5 per extra pound. Okay, so you get something like this. Okay, 26 times 5 plus 100. I think in one example before we look at the remainder, like how to calculate the remainder of the division, and like you can do this like in two ways. You can do this like using the remainder function or the mod function, and they return the remainder after division of A by B. Results is either 0 or, so like you get like the remainder of the division could be 0, like for example 10 divided by 5. What is the remainder of division for this? That is 0. Why? Because 10 divided by 5, they give you like 2, an integer of 2, and there is no remainder. Versus like 9 divided by 11 divided by 5, what would be the remainder of division? That would be 1. Why? Because 10 divided by 5, that's 2, that's the integer part, and the remaining part, that would be 1. Something like this. Okay? There is a slight, subtle difference between rem and mod. So rem will return the same size, same sign as A, and mod will return the same size as B. So basically, if both A and B are positive, then it's not going to make any difference. So let's just do something like this. So here, like, try to find the remainder of the division for like A and B. So here's a remainder of division of A and B, that should be 0.6. Because if I divided 15.6 by 5, I should get an integer of 3 and then the remainder of 0.6. So let's just try it here. So let's say RA is equal to rem, so like rem A over A and B. That's like, this is the rem function, and then Rm rem mod, like this is a modulus function a and b. And both of them should, in that case, should give like the same answer. So if we did this, so A is 15.6, B is, this guy is a reminder of the division is 0.6 and 0.6 and 0.6. So we got the same. By the way, how to get this integer part of this division? So remember, like 15 by 5, 15.6 by 5, the integer part of this division is 3. How to get this integer part? You can use fix. Remember, like fix will basically fix will like divide like the division of A over B. Let me show you what fix will do. Like, so you have like the division of A over B. That would be like 3 point whatever, and then fix or floor, that will round it to 0, and that's what we want, like round this number to 0, which will give you like the integer part. So like if I said like the integer part, that would be equal to fix a b. So if we did like fix a and b here, I should get like 3. Okay, I got like the 3 because a divided by b is 3 point something, and then I fix it or float it down, round it down towards 0. Okay, that's so if these two numbers are positive, there's no, you know, using rem or mod will give you the same answer, but there's a slight difference between them, because if one of them, or like A is like negative and B, for example, negative or positive, that will, let me show you this a little bit different. So let me show you this part here and this part here. So the remainder of the division, let me just do it here. So the remainder of the division, like when you divide this guy by this guy, the remainder of the division you expect is like negative 0.6, which we got here when we use the remainder functions, this rem function. But if we use the mod function, what you get is the answer would be something with the same sign as B. So the same sign as B here, that's like, basically it will, that is, remember, the remainder here is negative, but we need something as the same size sign as B. So basically it will take 5 minus the remainder of the division, it will give you 4.4. So you get like an answer like 4.4, same sign as B. If you have like, if you want to, we usually want to get the remainder of the division, so usually use the rem function. You only use the mod function if that's what you want to do. If you want to get like not the remainder of the division, but like a remainder of the division that has the same sign as B. Okay. Now let's do an example. You are designing a solar powered irrigation system for a farm. You have a solar panel with a maximum power output of 300 watts, a water pump that requires a constant power input of 100 watts. How many pumps can you operate with one panel, and what would be the remaining power? So basically, I have 300 watts, and each pump requires 110 watts, and I'm saying like how many pumps can I operate. Like basically I want to find like the integer part of the division, because there is no such thing as like 2.1 pumps or something like this. So in that case, yes. So power, pump power, solar panel power, the integer number of pumps, so that would be like n pumps. that would be the integer power of pumps. So basically that would be like the fix. So I divide the solar power that I have divided by the pump power that I have. So if I did this division, then I get like 2 pumps, okay? And now I want to find the remainder of the division, like how many power will be available if I want to use it for like some other application. So like we can say like the remainder, like remaining power, something like this. That would be like you use the remainder function. So basically you are dividing the solar panel powder time the number of pumps which you have. So you are basically like dividing not by 2, like the number of pumps time power of each pump. So basically like I have the number of pumps times the power of each pump. So I got like the remaining power, that would be 80. Okay, something like this. Now we did this before. Also we look at generating like random numbers. We looked at rand function before. So rand functions that create an array of random number uniformly distributed from 0 to 1, and that would be the number of rows, and m would be the number of column. Rand n that create an array of random number normally distributed with like a mean of 0 and standard deviation of 1. And rand I, we looked at rand I function before. Basically that create random integer numbers uniformly distributed between like the minimum range and the maximum range. So for example I want to, and that would be the number of rows and number of columns. Like I want to generate, for example, some random number from -1 to 4, for example. So -1 that would be the I minimum, and 4 that would be the I maximum. So I mean, let's look at each one of them. So like for example, if I said like just like let's call it like R1 is equal to rand, and for example if I run this, and it's undefined, let's put like 3 or 4. So if I did this, then I get like a 4 by 4 matrix with random number that from a uniform distribution from a range from 0 to 1, something like this. I could specify also the number of rows and columns that I need. So like for example, I need only like 4 rows and only 3 columns. So so I here specified like 4 of these and 3 of these. If I want just like a row vector, so that would be like rand 4, 1. So that will give me like a row vector. If I want, like here these numbers are just generated from 0 to 1. Let's say I want to generate these numbers from 0 to 10, for example. Like I want to random numbers uniformly distributed from 0 to 10. That would be just like the same as like, so here's just like rand, like let's say 1 and 4, and then time 10. So that will generate like 4 random number from, it will like, so you have a uniform distribution from 0 to 10, and you will sample 4 random number from this distribution. So you got here like 8 point something, 8 point something, 0.0, 0.3. Okay. If that range is negative, you can just like put like a negative sign. So I want to generate like from -5, for example, to 0. Like I have a distribution from like -5 to 0, and I want to generate like sample 6 random number from this distribution. So how to do sample 6 random number from this distribution? So like random, and then I want to sample like 6 number, and the distribution is from 0 to 5. So I put here 5. So here I have like 6 numbers that are randomly sampled from like a uniform distribution from -5 to 0. So I got like these values, something that looks like this. I can same things for the normal distribution. Like if I like rand n and I put like 3, for example, so that I will generate like a normal distribution, just like, so these are like 9 samples from a normal distribution with a mean of 0 and standard deviation of 1. Similar to what I did before, I can specify the number of rows and columns. So let's say like 2 and 3, for example. Then I got like 3 rows and 2 columns. I could also make this maybe 4 and 3 so I can show you. I can also so like you see, these are numbers from a random distribution with a mean of 0. Let's say my mean is not 0, like my mean is 10, for example. I have a mean of 10. So how to do this? Like you just add like whatever random number you generated, and like you shift them by 10, or like if it's -10, then you shift them by -10. So that would be like, let me erase this. So these are just some random distributions. This would be number generated from random distribution of a mean of 10. If the standard deviation is like not like 1, if it's like something else, then you can just multiply this by your standard deviation, and then that would be like, let's say, and for here I'm generating like some random number, like an array of 4 by 3 that include random number sample from a normal distribution with a mean of 10 and standard deviation of, let's say, let's make it very small, 0.001. So like you expect all the number to be very close to 10 when we do this. So you see here, like here you're getting some like 8 and 9, but here you get like everything very close to 10 because the standard deviation is very small, something like this. Okay, this is uniform random integer. I mean, like here I'm like generating an integer with a range. So I put like the maximum value. So I want some maximum value 5, for example, and I want to get like 4 numbers that like I want to sample like 4 integer from 0 to 5. So if I did this here, so sorry, not 4 integer, like here, if I put this will get me like a matrix, like an array that's like 4 by 4 with from 0 to 4. So you get like from 1 to this is from I think that's a mistake here. That's from 1 to n, not from 0. So that I put randomize uniform distribution. Yeah, so if I didn't specify like the minimum range, that would be from 1 to n. Okay, and I could specify like the size of my array, also similar to what I did before. So maybe I want to this like 4 times 3. So here I got like an array that's like 4 times 3 with some integer from 1 to 5, so not 0. If I want like a different, like my minimum value, not like 1, my minimum value like any other number, then I could also specify like the minimum and the maximum values that I want to sample from. So let me show you like RI3, that's like rand I, and then here I want this number to be from 5, minus 5 to 5, and I want to generate an array that is size 4 by 3, something like this. If I did this, then I got like some integer that are sampled from this distribution from minus 5 to 5 with a size of 4 times 3. Okay, so that is just this one. Let's do an exercise. So here, this is an exercise that says like use histogram function to plot a standard normal distribution. Normal distribution with mean 2 and standard deviation of 0.3, and uniform distribution from minus 5 to 5. So basically we want to plot these four things. For each distribution use 1 million samples. So we want to make 1 million sample. For the histogram use 1000 pins. Plot your for plot using subplot. For normal distribution plot, this is some formatting, and for subplot add title and grid on. Okay, so let's just do it. Let's start by the first one and then do the other one. So like let's start by the normal distribution. So I want like normal distribution. I want like 1 million sample from like a uniform. Okay, this normal distribution. Okay, so this like Rn, and how many samples do I need? 1 million. It's a lot of samples. So I create here. I put this is the number of rows. This is the number of column, and this is for this one. This is I put this here. Then I create like oh, I already have the number of samples, so I can just, instead of putting 1 million, I just put like the number of samples here, and then I make like subplot. And this is like 4 of them, so that would be like 2 times 2, and like the first one, and then I do like the histogram. So like the histogram, so I do like histogram, and what do I normal distribution, so whatever like I did here, and then the number of pins, which I already defined like as 1000. It tells me for this one, set the x and y limit to this number for the normal distribution plot. So here, like you say, like x limit whichever numbers that I have here, and then the y limit that's the y limit, not the x limit. Y limit, and the x limit, that should be whichever number I have here. And then let's say like grid on, I can just do this one. And then normal distribution with mean of 0 and standard deviation of 1. Let's just run this one and see how it will look like. See, it's taking some time to compute because I think it's a lot of sample. Grid on, yes, I mean. So, okay, so you see we got like a very nice like normal distribution here. Now we can do the same thing. So let's just copy and paste. We can do the same thing like normal distribution. What is the mean of the other one? Normal distribution with mean 2 and standard deviation of 0.3. So normal distribution with a mean 2 and standard deviation of 0.3. So let's call this like normal distribution. Let's call this like standard normal distribution. Maybe that's easier. Standard normal distribution, and let's just call this like normal distribution. Here we right standard normal distribution. Yes. Here like the normal distribution with a mean of 2 and standard deviation of 0.3, so it should be a little bit more skinny than the one we got here because it has like smaller standard deviation. So if we plotted this, okay, so here we got like this is like the sorry, I mean this I didn't change this here. It should be like the mean should be 2 and the standard deviation should be 0.3. So multiply by 0.3. Okay, so here we got like something, the mean here is 2 and like it's a little bit more skinny than the other one. You can do the same for the uniform distribution. So if he like standard uniform distribution, standard uniform distribution, so let's go like standard uniform distribution. So that would be again like this one, the same number of samples. That would be plot number 3. Maybe we can remove this one. We can put grid on like what do you call it? Standard distribution, something like this. Okay, so I mean let's just do all of them like, and then it says like the other one is uniform distribution from which range? From -5 to 5. Uniform distribution from -5 to 5. So here uniform distribution, let's just call this number 1, and that would be times 5. And again here like I need to, so I will just use half of the sample from like 0 to 5 and the other half from -5 to 0. Okay, so just half of the sample here, and then I can do this one. So this would be the negative one, and then like to have both of them, that would be the positive sample and like the negative sample, something like this. Okay. I mean, probably there are so many other ways of doing this than what I did here, but I mean, that is just what we did here. So here, uniform distribution, we can call this one uniform distribution from -5 to 5. Okay, and let's just do the plotting. Okay, so now I think there's something I did wrong here. Yes, I didn't change this on the histogram, so that should be this data set. So this is like what I'm plotting here, and this should be the histogram. That should be this data set, like this is what I'm plotting here. Okay, so let's just do it. So okay, so here we got, like, let me make it maybe a little bit bigger. Open window. Okay, my computer is a little bit slow, but anyway, you see here, this is let me try one more time. Okay, now it's working. Oops, oh, I opened so many of them. Okay, let me do it one more time. Need to be patient, but okay, here we go. So here you see like a normal, standard normal distribution. You see like a normal distribution with a mean of 2 and standard deviation of 0.7. Here you see standard uniform distribution from 0 to 1, some random sample, and here from -5 to 10, something like this. Okay. Now the last part of this is telling you create a table with the mean and standard deviation for each distribution. Like, so table, that should be easy. Like, that should be the mean of just need to remember what we call them. The mean of what we call the what do we call this guy? I think some other one, like, which I'm putting here. Okay, let's just see what we did here. So the mean of what did we call this guy? S and D, standard normal distribution, and the standard deviation of standard normal distribution. Okay, and then we go to the mean of the normal distribution. I think that's what we call this guy, and standard deviation of the normal distribution, and then the new row, and then the mean of the, what did we call, like, this guy is the uniform distribution and standard deviation of the standard uniform distribution. Okay, and then mean of the uniform distribution and standard deviation of the uniform distribution. Okay. So like you see, we just like the mean of this one, like the standard normal, almost 0, the standard deviation is almost 1. As the larger number of sample goes, then this number will converge to 0 and this number will converge to 1. For this one, the mean is almost 2, the standard deviation is like 0.3, like this is what we used. And here, this would be for the uniform distribution. Okay, so now we have here some extra problem if you want to practice more. So this, you can like do this exercise, and like here I provided the solution here for you. And here is some like engineering problem, like if you want to see like what is the application of these things in like some application in engineering, I put like some engineering problem here about like signal processing. I mean, you can read like these details. Okay, so that's all for this lesson, and like see you in the next lesson. Bye bye.